In our next section, we're going to look at the configuration of ISIS on JunOS, which is controlled by the family ISO, because ultimately behind the scenes, ISIS uses CLNS, which is part of the ISO protocol stack. One of the changes from iOS versus JunOS's implementation of this is that the router ID, or specifically what we call the network entity title or the NET address from ISIS, is not defined under the global process, but instead it is defined under interface loopback 0. So we go to the interfaces that we want to enable ISIS on, we activate the address family ISO, and then specify the NET address basically as an ISO address on the loopback. Then under the global process, we can selectively choose whether we want to enable ISIS for IPv4 routing versus IPv6. So just like we do in iOS, we can have a single SPF run for both of them, which is called single topology ISIS, or we can separate the topologies into two different SPF runs, which is also known as multi-topology ISIS. So from a general config point of view, the first thing that we're going to do is to define the NET address under the loopback. So that's going to be under family ISO, and we set the address. And then we specify what are the other interfaces running IPv4 or IPv6 that we want to enable ISIS on. Activate the address family ISO and also the protocol ISIS under the interface for ISIS under the process. Now, in terms of iOS, normally we would do this by first starting a global ISIS process, router ISIS, and we can give it a name if we want, and then specify what the network entity title is. So let's say, for example, that we're going to run single area ISIS here, so a single level, and we're going to be using the area 49.0001, followed by the system ID, which is basically the router ID within the particular area. So on CSR1, we're going to say that the network entity title or the NET address is 49.0001, and then the system ID is going to be all ones. Okay, a NET address always ends in 00. Then in the case of iOS, we would go to the link level, for example, the gig1.12, and say IP router ISIS, and then whatever the particular tag is. Okay, also we would normally go to the global process and say passive interface loopback 0. This means to enable ISIS on the link, but we're not actually forming an adjacency. Now, in the case of JunOS, if we look at SRX1, we would go to the loopback first and enable the ISO family. So we're going to go to config, and we're going to edit interfaces loopback 0, unit 0, and set the family ISO address. So this is going to be similar to the network entity title command, or the net command under iOS. So we're going to have the same area. We're going to say that the area is 49.0001. Then our router ID is going to be 2222.2222.2222.00. Okay, we still need to edit on the interfaces that we want to enable the process on, which in this case is going to be gigi-000.12. So we're going to top edit interfaces gigi-000.12 and say we want to set family ISO, so that's enabling CLNS processing. And then we'll say the same thing on gig 23 and on gig 24. Okay, so essentially all of the interfaces we're going to run ISIS. If we look at the top show pipe compare, we have enabled CLNS processing on the interfaces, but we have not yet enabled ISIS for those particular links. So it's two separate steps to do it at the interface level, and then also we're going to edit protocols ISIS, top edit protocols ISIS, and we're going to set the interfaces so that the process is actually enabled on them. So again here, whether we're issuing the dot format for the interface or whether we're issuing the unit, it's essentially the same. So I could say set interface gigi-000 unit 23 or dot 23. Okay, we can see when we look at the config here, these are referenced as the units. Okay, then we'll top show, pipe compare, commit and quit. Okay, on the iOS side, if we look at the show ISIS neighbors, what we should see here shortly is that we learn about the network entity title of that particular neighbor. Okay, notice here that the type of adjacency is ISIS level 2. We should also here shortly start to receive level 1 hellos as well. So just like as we do in iOS, it should be running as both levels, assuming that I have the same area ID. Let's say show run include NET 490001. What did I specify it here? Yeah, that's the same area. Let's say show ISIS neighbors. Show ISIS adjacency, actually. This is for, so they're not fully adjacent yet, is what the issue is. But here it says it's for level 1 and level 2. So this is similar to iOS behavior. Unless we specify what database we want to run on the interface, we're going to be running both level 1 and level 2. And in most real designs, you wouldn't do it that way. You're going to run normally level 2 everywhere, and then if you want to run inter-area routing, you have one of the routers run level 1, level 2, similar to an area border router in OSPF. So basically, with the default behavior, you're doubling the size of the routing database. Because we don't need 2 separate adjacencies, we really only need 1. Okay, if we look at the show IP route ISIS, okay, we can see that it is advertising those connected links. So these are the links that we have ISIS processing enabled on. If we wanted to advertise the loopback, we're going to have to enable that. So if we go to global config, if we edit protocols ISIS, and we'll set interface loopback 0.0 commit. Okay, now we can see we have the loopback being learned as well. Okay, the loopback interface, we can see it's level 2, where the other interfaces are level 1. If we look at from the SRX point of view, if we look at the show, let's exit config first here. Show ISIS interfaces brief. And actually, let's say show ISIS interfaces detail. We can see that all of these interfaces are running both level 1 and level 2. So in the case of iOS, there's 2 different ways that you can do this. You can either go to the link level, and you can say the ISIS circuit type is either level 1 or level 2, or you could go globally under the process and say the IS type is either level 1 or level 2. Normally, you're going to do this, you normally would do it globally on someone who is a level 1 only router or a level 2 only router, and then the device that is the L1, L2 router, basically the area border router, then you would do that at the individual link level. So here on iOS, if we were to say that we're running level 2 only, in the case of JunOS, what we would do is this is going to be under the ISIS process globally. So if we go to config and edit protocols ISIS, we're going to, let's say, show edit interface gigi 000.12. We would set the level, for example, level 1, and we would disable it. So this here, if we show pipe display set, This is the equivalent of the ISIS circuit type command at the link level in iOS. Okay, so let's say we also want to enable this on vSRX2, so we're going to form an ISIS adjacency between these two routers. So let's go to SRX2. We're going to go to config. We're going to edit interface as loopback 0, unit 0, and we're going to set the family ISO. Okay, again, the address that we're using here, this is the network entity title. Then we will set interface gig E000, set gig E00024, family ISO, and the same with the other interfaces. So gig 3446, for example. Okay, then under the global process, if we top edit protocols ISIS, we're going to set interface gig E00024, 3446. So basically whatever other interfaces that we matched or that we enabled the family ISO on. So if we top show pipe compare, it's essentially two steps again, under the link level and then also under the global process. If we commit and quit, we should see that we form an adjacency between the two JunOS boxes if we show ISIS adjacencies. And once we converge here, once the actual adjacency state is up, we're going to look at the show ISIS database and the show ISIS database detail. Now notice here that as I mentioned, we're running both level 1 and level 2. So the database is going to contain the NLRI for both level 1 and level 2. But notice here by default, it's containing both IPv4 and IPv6. Where in the case of iOS, normally you configure those as two separate protocols, where you would either go into the address family under the ISIS config, or you would say IPv6 router ISIS at the link level. But in the case of JunOS, it's assuming that since you have ISO on the link and you have the families iNet and iNet6, that you want to advertise both of the routes. So if we were to look at the show route protocol ISIS, we see that we're learning not only the IPv4 routes, but also the IPv6 routes. Now, from regular iOS's point of view, there's essentially an incompatibility with this because it's not running both address families by default. So only if we look at the show IP route ISIS, right now we're not able to actually install anything that we're learning from JunOS because we don't support the same exact address families as they do. So in iOS, we would need to go under the ISIS process, and we would, actually not under the process, we'll go into the link level, and say IPv6 router ISIS. And also, I believe we need to enable the new TLVs, which is under metric style wide. Metric dash style wide. Okay, so we can see now from the iOS side, now it's advertising both its IPv4 addresses and its IPv6 addresses. So we have the v4 routes now. We don't yet have the v6 routes. But this is one of the other things that you would need to take into account if you were doing interoperability between iOS and JunOS for ISIS, is you need to make sure that the metric style is compatible between them, and then also that they're either both running single topology or both running multi-topology, because if there's a mismatch when they go to run SPF, they end up in different results, and then they're not able to actually install the routes into the routing table. Now, this is assuming that we have both address families, that we have v4 and v6. If we didn't want to enable the advertisement of v6, the way that you would do that under JunOS is under the process. If we go to config, we edit protocols ISIS. If we look at the config currently, we have those interfaces. We would say interface gig E, edit interface gig E 00024, and we would say set no-IPv6-unicast. So don't include that in the IPv6 unicast topology. Okay, same would be true of the other interfaces. Okay, you can also see the other options similar to OSPF. We do this under protocols, under OSPF or ISIS, under the interface level, and then we have the specific options. So for example, if we wanted to run bidirectional forwarding detection, that's under protocols, ISIS interface, the specific link, and then BFD liveness detection. If we wanted to change the hello intervals, the dead interval, make this a passive interface, say whether we want to pad the hellos to the MTU or not, what the specific level that we're forming adjacency with, most of that stuff is going to be under the interface. But the major change in syntax here, as we saw when we show config, pipe display set, is that the network entity title goes under the loopback as an ISO address. Then the other interfaces, for example, gigi unit 34, we need to enable family ISO, and then also enable this under the ISIS process. When we actually go to learn routes, if we look at the exit config, and we show route protocol ISIS, we can see that the preference is 18, which again is similar to the administrative distance in the case of iOS. If we were to do redistribution, let's say, for example, we went to our iOS box and we did something like this. Let's say IP route 1234 goes to null 0. Then under ISIS, let's say redistribute static into level 2. When we learn this on the JunOS side and show route, let's just say show route. So let's see, is iOS advertising that? Let's say show ISIS database detail. It should be advertising the external route 1234. Well, something is causing the adjacency to flag. I think probably the boxes need to be reloaded because there's so many changes I've been making. But in any case, the point is that there's a difference between the internal and the external preference. So like how Cisco does that with EdgeRP, you have internal routes that are preferred over externals. JunOS does that both for OSPF and for ISIS. That OSPF internal is preferred over OSPF external. ISIS internal is going to be preferred over ISIS external, and then it also depends on whether it is a level 1 route versus a level 2 route.